Good morning. Today I want to present about our database assignment. We are from Group 5. Okay, next. Okay. First, I want to talk about the characteristic of the relational table. Okay, there are 6 types. Okay, first is the values are atomic. All of the value in the column must have the same data type. Okay. Each row is unique, and also the sequence of column and rows is insignificant. Okay, each column has a unique name. Okay, integrity constraints maintain data consistency across the multiple table. Next, I want to talk about the dependencies. Okay, dependencies. The key role is based on the concept of determination. Okay, knowing the value of an attribute is make it possible to determine the state of the value of another attribute, and also it is the basis for build the key role, and also it is based on the relationship between the attribute. Okay, the dependencies have 2 types. Okay, first is the functional dependence. If it can be determined by this attribute, the attribute is functionally dependent on another attribute. And the second one is fully functional dependencies. The entire set of attributes that in the determinant is necessary for the relationship. Okay, next is the type of key. There are 6 types of keys. Okay, first is the composite key. The composite key is a key consisting of 1 or more attributes. Okay, the second one is primary key. Primary key is an attribute or combination of attributes that uniquely identify any given row. Okay, super key is uniquely identify 1 or more attributes for each entity in the table. Okay, candidate key is the super key without redundancy. And also the foreign key is 1 or more attribute in the table whose value must match the primary key in another table. The last one is secondary key. Secondary key is a key that is strictly used for data retrieval purpose. Okay, next I want to talk about the integrity rules. Integrity rules have 2 types. First is entity integrity and referential integrity. Okay, let's talk about their requirement. The requirement of entity integrity is all primary key entries are unique and no part of the primary key can be known. The referential integrity requirement is foreign key can have no entry or an entry that match the primary key value in its associate table. Okay, next I want to talk about the purpose. Okay, the purpose of the entity integrity is each row has a unique identifier and the foreign key value can correctly reference the primary key value. Okay, the purpose of referential integrity is attribute may not have corresponding value but that may not be invalid entries. Okay, next I want to talk about their example. The example of entity integrity is no invoice can have duplicate number and can be empty. Okay, the example of relational integrity is IA customer may not have a designated sales representative yet, but cannot obtain an invalid sales representative number. Okay.
Good day to everyone. Today I would like to talk about ERD. ERD stands for Entity Relationship Diagram, and it is also a snapshot of a data structure. And ERD shows entities in database and relationship between tables within the database. ERD also shows relationship of entities set stored in a database. There are 3 main components in ERD. First one is entities, attributes, and relationship. Entities have 2 types of entities. It is associative entities and weak entities. Entities is the thing for which we want to store information in it. And the associative entities is referred to as composite or bridge entities. Associative entities may contain additional attributes that plays no role in cognitive process, and it is used to represent a many to none relationship between 2 or more entities. Now I would like to talk about the weak entities. Weak entities is an entity that could not be uniquely identified by its attributes alone, and it is existence dependent. Weak entity has a primary key that is partially or totally derived from parent entities in a relationship. Next, I would like to talk about attributes. Attribute is the data we want to collect for an entities. It is referred as characteristic of entities. Now, I would like to talk about relationship. Relationship is the relation between the entities. It can allow relational databases to split and store data in different tables. There are three types of relationship: one-to-one, one-to-many, and many-to-many. One-to-one is both tables can only have one record. One-to-many is primary key table have only one record that relates to none, one, or many records. And many-to-many, each table in both table can relate to any number of records or even no records in the other table. Now I would like to talk about constraints. Constraint is the rules that enforce on data columns of a table in database. Can either be on a column level or table level. There are 5 types of constraint: check constraint, unique key constraint, primary key constraint, foreign key constraint, and not null constraint. Okay, thank you. That is my part.
Okay, and now I would like to continue to talk about the basic relationship. Basic relationship categorized into 3. The first one is one-to-one. A one-to-one relationship, each item of relationship can be associated with only 0 or 1 item of another entity. Okay, here is one of the example. A citizen has one ID card, and an ID card is owned by a citizen. Citizen, yeah, ID card. So a citizen has one ID card, and ID card is owned by a citizen. Okay, another basic relationship is many-to-many. Many-to-many is the relation where multiple rows from table A can correspond to multiple rows in table B. For example, a customer can purchase various products, and a product can be purchased by many customers. Customer purchase product. Customer can purchase various products. And a product can purchase by various customers. Okay. Next, I would like to talk about the one-to-many relationship. One-to-many relationship is one record in the table can be associated in one or more record in another table. So this is an example. Like individual student can working on any project at a time. Yeah. One student can working on many projects at a time. Project must be working by a student. This is a one-to-many relationship. Okay, that's all for my part. Thank you.
For this section, I will show you how to do a business rule and try to do a closed food EID based on this business rule. Okay? Let's read this. A doctor may assign to many different departments in the hospital, but each department must contain one or many doctors. So, as you can see, a doctor is the entity, and the department is the entity also. Okay? And what is their relationship? Their relationship is many-to-many because a doctor may assign to many different departments, and each department must have one or many doctors. Okay? So the relationship is many-to-many. Okay? The doctor ID, unique, name, email, and contact number is stored, which shows that that is the attributes of the doctor's entity. Okay. Next is the department. So name and location is also the attribute for the department entity. Okay. A doctor can be scheduled for many appointments, but may not have scheduled at all. Each appointment is scheduled exactly a doctor. One doctor. Okay. A doctor can be scheduled for many appointments. So appointment is one of the entity, and doctor is also the entity, but we do not need to write it again because up here is we already identified it's a doctor, it's the entity. So what is doctor and appointment relationship is one to many, because a doctor can be scheduled for many. Is one, and it's also a participant question because it's may or may not be scheduled. Okay. And each appointment schedule will exactly a doctor, so one to many. The appointment time, date, duration, and reason is also the attribute for the appointment entity. A patient can schedule for one or more appointment. One appointment is scheduled with exactly one patient. Okay, so a patient is also one of the entity, and appointment is also the entity. That's above here, we already showed it. So, what is their relationship? A patient can schedule for one or more. One or more, so it's one to many. And one appointment is scheduled with exactly one patient, so one to many. Patient ID, name, address, and contact number is stored. So, with this we can see that this is the attribute. A patient can only own one medical card. A medical card can only be owned by one patient. So patient is the entity, and one medical card is also the entity. So what is their relationship? It's one to one. Okay? Because a patient can only own one, so it's one to one. And by medical card source, names, and type of the medical card. So this is their attribute. And now I will show you how to draw the ERD based on this business rule. Now I will show you how to draw the ERD, Crowfoot ERD based on the business rule. Okay, first, just now as you see, a doctor may assign to many different departments in the hospital, but each department must contain one or more or many doctors. So you should know that that is many to many. So we cannot directly go here, down here, many. We have to have an entity at the middle. So what is the entity at the middle? Is assign, because a doctor needs to assign to a department. So first entity is doctor. Okay. Second entity is assign. And for below here, we put department. Okay. So what is their attribute? So first attribute, you need to identify the primary key. So as you can see, the doctor ID is unique, so it's automatically the primary key. So you can just write doctor underscore ID. Okay, and the other attribute you just continue writing. So this attribute, so assign, it didn't specify what to store, so we can leave it blank. But the primary key we must also put it. So what is the primary key for the assign? Is assign underscore ID. Okay? And for department, go back to the business rule and see what is the primary key. So as you can see there just now, they didn't specify what is the uniqueness in the business rule for department. So we can just create a primary key for ourselves called ID, because ID is always unique. Okay? So we put department ID. And continue with their attributes. So as for foreign key, because we are using the assign, we need to store the foreign key right here. Okay? So because assign need to be used by doctor and assign need to be used by department. So we put foreign key, their primary key. Okay? So here will be doctor ID and department ID. Okay. For their relationship, we put, so a doctor may assign to one or more departments in the hospital. So assign one or many. So one or many. And a department need to be assigned one or many doctors. So put this symbol like this. Okay? Next, a doctor can be scheduled for many appointments. Okay? So the appointment is the entity. So we write here appointment. And identify what is their primary key. So it also didn't specify, so we create our own. So appointment ID and write their attributes, which is time, date, duration, and reason. For the foreign key, we put an appointment because appointment needs the primary key of doctor ID to be used. Okay, so we put doctor. Okay. Next is the relationship. So the doctor, doctor can be scheduled for many appointments. So and each appointment is scheduled with exactly one doctor. So it's one to many because of the just now I explained. So one doctor can have many appointments, but an appointment must have one doctor. Okay. So next is a patient. Okay, a patient can schedule to one or more appointment, and one appointment is scheduled with exactly one patient. So patient is one of the entity, and their primary key, as you can see, patient ID. Patient ID is the primary key because ID is unique all the time. And write down their entity. What is their relationship? So an appointment can be one patient can schedule for one or more appointments. So as you can see, it's one to many. So one patient can assign many appointments, and one appointment can be scheduled to only one patient. And what is the foreign key? Where we put the foreign key is at appointment because appointment is patient's primary key to be used. Okay, so we put patient. Okay. Next is a patient can only own one medical card, and a medical card can be owned by one patient. So medical card is one of the entities. Okay. And what is the primary key? So we need to create our own primary keys, which is medical card. their entities. What is their relationship? It's one-to-one because a patient can only own one medical card and one medical card can be owned by one patient. So one, and one, like this. And where we put authority is at medical card because we need patient ID to own a medical card. Okay. So, next we have to put to describe the relationship here. So a doctor have assigned a department as put have as here, and doctor is scheduled for appointment. So we put scheduled here. And for a patient can schedule an appointment. So we can put here schedule. And patient can own a medical card, so we put own to describe their relationship. What is their relationship? Okay, next we need to write what. So here we can write 1-to-1. Or is 1-to-1, and so doctor can assign one to many. So here we put one to many, and here one to many because it doesn't say one to many or two or more. And a doctor can, so here is because doctor may. There's one sentence called. The doctor may not have scheduled at all, so my mistake here should be 0 because it may or may not have been scheduled, the doctor. So here should be 0 or many, so it's a participant constraint. So here we put 1-to-1. Okay, one doctor can schedule appointment, but sometimes the doctor is not scheduled. Okay, here we put a patient can assign one or many appointment, and this one we put one because a patient can be assigned appointment can be scheduled by only one patient, and here we put 1-to-1, because patient can own a medical card can be owned by one patient. Okay, so that concludes this Ghoh Rie EID, and I hope you understand, and thank you.